In fact, last class I told about the contents of OR syllabus. I told you already.
Sir, on the
Unit 1.
recording.
Yeah. Good. Thank you for remembering because it was very important. Afterwards, asked me to share, no, yeah, record started. Yes. Yeah, last class I told about the unit-wise chapters and also difficulty level. I told about the first chapter talking about LPP, that is linear programming problems. And we are going to use three methods to solve OR problems, that is LP problems in the first unit. Little bit difficult. Second unit talking about transportation, assignment, and traveling salesman problems. Relatively easy, but of course, unless you practice, difficult because it takes a lot of time to transport to calculate transportation cost. Unit number 2. Unit number 3, that's about potent CPM, where we're drawing the networks. Okay, potent CPM was very good, in fact, a good chapter. Of course, little bit theory there, only 5-6 marks theory. Of course, in each unit, we're going to give at least 4 to 6 marks theory in each unit. Okay, and fourth unit talking about sequencing and waiting lines, that is queuing theory, relatively good chapter. And lastly, game theory, that is unit number 5, very easy compared to all the units. If I'm not getting electronic gadgets to start LPP, I think I'm thinking of starting unit 5 after completing the first unit theory portion. So that's what I planned for this OR class till 30th of September. We'll see later afterwards what happens now. Okay, next regarding theory portion, that is I told about textbook also. Textbook you can refer S.T. Sharma, okay, or even Gupta, and also there are so many books are available. But I'll let you know when start coming to college and all. Okay, you don't have to worry about textbook right now. Just focus only on the PPTs what I'm going to share with you all. Okay, start with introduction to OR, that is operations research. So just here, the topics intended to cover in this theory portion is introduction to OR and history of OR. Little bit, I'm not going to cover completely. You don't worry that I'm going to take completely for this things now. OR in India, the definition of OR, features, scope, steps in OR, and two techniques we are going to use in OR, and of course OR and decision making. These are the topics we're trying to cover in this unit 1. Okay, so introduction to OR. OR basically a systematic and analytical approach to decision making and problem solving. I told that all these OR basically consists of only analytical problems. It's systematic and analytical approach to decision making and problem solving. It is typically concerned with determining the maximum profit, sale, output, crops yield, and efficiency, and minimum losses, risks, cost, and time. Basically, this maximization and minimization is termed as objective function. I'm going to explain you when solving problems. Mainly, we are going to focus on the objective function of linear programming problems, LPP, wherein we are trying to achieve two things, either maximization or minimization. What you can maximize? Maximize the profit for organization, maximize the sales, maximize the output, or maximize the crops. Nothing but you can say yield improvement, or you can improve the efficiency. That is maximization. Minimization. What you can minimize? Minimize the losses, minimize the cost, minimize the risks, minimize the time. These can be reduced. So basically, the objective function is focusing on either maximizing or minimizing. So OR is focusing on maximizing or minimizing, maximizing profit or minimizing cost. History of OR. I told a little bit about in the last class. The origin of OR started during the Second World War. There is no clear history that marks the birth of OR. It is generally accepted that the field originated in England during the World War II. Modern OR originated in UK to analyze and improve the working of UK's early warning radar system. So they used for defense basically. After World War II, military operation research in UK became OR, that is OA, that is operation analysis within UK. Ministry of Defense with expanded techniques and graving awarenesses. Okay, So originally it started in the UK only. Of course, in India, so as of now, people are not much using this OR, though it is a good decision-making technique or management science or computer techniques also. Even the subject is very common for MCA, MBA, and mechanical, production, automobile, and all. Even computer science also, this subject is very important because it involves a lot of mathematical calculations. But still, OR is not finding much scope in Indian industries. But of course, in abroad, if you're going for MS and all, really you find lots of applications of OR when you're going to you do your MTech and all. But of course, even GATE also, you're going to get one or two questions from OR. OR in India. OR Society of India was founded in 1957 to provide a forum for the operation research scientists as well as an avenue to widen their horizon by exchange of knowledge and application of techniques from outside the country. The headquarters of the society is located in Kolkata. In fact, Kolkata is famous for two things. One is, of course, related to engineering, I'm telling about. So, one is, of course, the Indian Statistical Institute. Okay. And the second thing is War Society. These two are located in Kolkata only. Okay, just coming to the main part of war, that is definition of war. War can be defined with many definitions. One, of course, it's a scientific approach to problem solving for executive management. Okay, I told the very important term here in war definition is it's a scientific approach to problem solving for executive management. You can say one more definition. It is an art of giving bad answers to problem which otherwise have worse answers. It is basically talking about optimization. We're expecting that the answer may be or the solution may be worse, but trying to minimize the worst condition, you're going to get some bad answers. So we can say that bad is better than worse. Worse is better than worst. So that's why you can say it's an art of giving bad answers to problem solving, otherwise it becomes worst. One second, no, that is in. Okay, and I have given the definition by referring textbook. Application of scientific methods to solve managerial problems in an organization. Okay, that is the definition of war. You can write anyone. Okay, you can write the scientific approach to problem solving for executive management, or you can write the art of giving bad answers to the problem which otherwise have worse conditional answers, or you can write the definition as application of scientific methods to solve managerial problems in an organization. Okay, you can write any definition. Just to check out any chat box, anything is there. You can always free to write anything on chat box. Good morning, good morning, good morning. Nothing else. Okay. I want to check frequently the chat box. So you can write anything in the chat box if you want. So this is about definition of war. Now, features of war. Okay. It's a decision making. And it's a decision-making tool. Second thing, it is a scientific approach. Third, it is interdisciplinary team approach. And it has a system approach. And war uses computers. And war works on some objectives. I told minimization and maximization. These are the features of war: decision-making, scientific approach, interdisciplinary team approach, system approach, use of computers, and set of objectives. So we'll go a little bit details about these features. What do you mean by decision making? Every industrial organization faces multifaceted problems to identify best possible solution to their problems. War aims to help the executives to obtain optimal solution with the use of war techniques. I told war focusing on obtaining the optimal solution. That's why you can say it's the art of giving bad answers. Otherwise, it's going to be worse answer. So it's trying to improve the solution. It helps the executives to obtain optimal solution with the use of war techniques. It also helps the decision maker to improve his creative and the judicious capabilities, analyze and understand the problem situation, leading to better control, better coordination, better systems, and finally, better decisions. Just to go to the last paragraph, OR helps the decision maker to improve his creative and judicious capabilities, analyze, understand the problem situation, leading to better control, better coordination, better systems, and finally, better decisions. It's the first feature of OR. Okay, that's the decision maker to improve the analysis of the executives. First feature of OR. Second feature, scientific approach. OR applies scientific methods, techniques, and tools for the purpose of analysis and solution for the complex problems. Whatever the method you are going to use, whether you are going to use LPP, that is the linear programming problem, whether you are going to use the transportation, whether you are going to use sequencing, whether you are going to use a pattern CPM or game theory, each methods are using scientific approach only. They have got some set of procedure followed. You can't simply randomly solve. Normally, mathematics, you say that mathematics is a scientific approach. You can't simply go with some solution. But management and all, where you can give multiple answers. Say, for example, definition of OR, you can come out with the 10 definitions. Definition of management, you can come with the 10 definitions because anything that leads to the definition of any management at all. But here, when you go and say that any methods or tools you are going to use, they follow some scientific approach. So that's why you can say the second feature of OR is scientific approach. It applies scientific methods, techniques, and tools for the purpose of analysis and solution for the complex problem. Second feature of OR. First one, decision making. Second one, scientific approach. And thirdly, it is interdisciplinary team approach. OR involves lots of people from different areas. The industrial problems are of complex nature and therefore require team effort to handle it. Okay, anything you take a manufacturing scenario or any industrial problems are always of some complex nature. Okay, so therefore it requires a team effort to handle it. One can't handle all the problems because typically any manufacturing concern deals with the suppliers supplying raw materials, supplying the machineries, equipments, tools, and all those things to suppliers. Then talk about the manufacturing. When you say manufacturing, you're going to get once again purchasing, design, and testing, production, quality control, marketing, advertisement. Because the multi-facets are there. Once you have this one in the marketing, then you're going to have distribution channels, then you're going to get the wholesalers, retailers, agents, and all. Then you're going to get customers and all. So it is a multi-facet problem. So typically, you can say that industrial problems are complex in nature. That's why one person can't handle the problems. So it requires a team effort to handle it. This team comprises of scientists, mathematicians, and engineers who jointly use the OR tools to obtain an optimal solution for the problem. Okay, so this is talking about how OR is developed. Okay, that's why you can say OR is a interdisciplinary approach. It tries to analyze the cause and effect relationship between various parameters of the problem and evaluates the outcome of various alternative strategies. Okay, so the third feature of OR is interdisciplinary team approach because it comprises of many people across various fields like statistics, scientists, mathematics, we can say physics, chemistry, statistics, mathematics, computers, engineers, likewise all the people involved to make one operational analysis. That is called as OR. That's why OR is also called as management science. OR also called as optimization technique. OR also called as quantitative techniques. They called as QT, OT, MS, likewise multiple names are there for OR. They try to analyze the cause and effect relationship between various parameters of the problem and evaluate the outcome of various alternative strategies. When you start solving any problem, you come up with multiple strategies to solve, and evaluating the best strategy is very important. OR tries to give solution that which strategy can be used to achieve the objective. Okay, that's why I can say that it is a interdisciplinary team approach. The third feature of OR. And the fourth feature, system approach. Remember here, a system, what do you mean by system? Okay, you say you won't give any examples. Education system is there, or you can say our own body, our respiratory system is there, or you can say we have digestive system is there, or you can say that hospital system is there. Okay, when you say that anything, it has got something called as a system. Okay, system consists of relatively some of the subsystems which are going to work together to achieve the objective of the system. For example, you have a computer system. It's a system in fact. Computer system has got an input, it has got a processing unit, it has got an output system. So these three, that is input, process, output, these three constitute the computer system. Okay, input you're going to provide data and you're going to process logically or arithmetically, and you're going to get some output in terms of printout on the screen and all. Okay, so this is the system data. So here we have some subsystem called as input, one more subsystem, and the processing, one more subsystem, and output, one more subsystem. So all these subsystems is going to constitute one system. Okay, so we can say that OR also, we can say that it can't be applicable to only one department, one organization, one section and all. We can say it approach to apply to entire system. It will go take it as a system as a whole. Okay, organization as a whole. So that's why I can say the fourth feature of OR is used for actually system approach only. The main aim of the system approach is to trace out all significant and indirect effects for each proposal on all subsystem on a system, and to evaluate each action in terms of effects for the system as a whole. Okay, I told the same thing example of a computer system. You have input, you have processing, you have output. So if you go to take that input as one of the subsystem, you're going to have once again a subsystem also in that input also. When you're going to say processing unit, okay, it's going to have multiple once again logical unit and all. They're going to have once again some systems. So we are trying to we're going to try to take coordination of all systems, subsystems, and making a system. Okay, the internship and the interaction of each subsystem can be handled with the help of mathematical or analytical models of OR to obtain acceptable solution. Okay. So remember the last sentence, paragraph, you can say it. The interrelationship and interaction of each subsystem can be handled with the help of mathematical or analytical models of OR to obtain acceptable solution. Okay, that's why I can say system approach. It's going to take into account all subsystems in the organization and going to see as a holistic approach. Nothing but you can say system approach. It's the fourth feature of OR. And fifth feature of OR, use of computers. Why do we need computers in OR? So for example, let us say any problems we are going to express using mathematical symbols, algebraic symbols, say x1, x2. For example, you take x1, x2 are the two variables, and say for example, you're going to have only 2 or 3 constraints, like they have got some raw material constraint, let us say they have got some capital constraint, they have got some human resource constraint. Imagine you have only 2 variables and the 3 constraints, because they are the linear equations, you can solve graphically, you can come out with any solution by manually you can solve it. But it's not going to be so simple when you talk about the major bigger organizations and all. There you're going to get multiple number of variables. So for example, if company manufactures only one product, we can say X1 appends that product. If company manufactures 100 products, then how do you say it? How do you going to express in terms of 100 X1, X1, X2, X3 up to X100? Then they're going to hundreds of variables, and correspondingly you're going to get multiple number of constraints. That you're going to get 25, 30 constraints. Okay, so you can't solve mathematics manually. So you need to have the computers. That's why use of computers is very essential in OR. So one more feature of OR is use of computers. The models of OR need a lot of computation, and therefore the use of computers become necessary. With the use of computers, it is possible to handle complex problems requiring large amount of calculations. The objective of the operations research models is to attempt and to locate best or optimal solution. I told that we're trying to get the best solution, or at least we're going to try to get the optimal solution. So to handle complex problems, there is a need of computers. The fifth feature of OR is use of computers. And the last feature of computer. So always OR works on the objective. Okay, you heard of this one. No? Objective is very essential. For example, you talk about mission, vision, and all. Any organization, I think you would have seen everywhere. That is, we have the mission, we have our vision also. So the objective is very important. When you're going to start anything, what is the objective? What's the aim of this one? Okay, just like you have to experiment. Likewise, again, you're going to get to the objective. OR always try to find the best and optimal solution for the problem. For this purpose, objectives of the organization are defined and analyzed. Very essential that it is object oriented. Okay, I think probably in M&E, I think maybe in fifth semester I might have studied M&E where MBO, it is management by objectives, because we are trying to define the objectives and all efforts are trying to achieve the objectives. So the purpose of objectives of organization are defined and analyzed. These objectives are then used as a basis to compare the alternative course of action. I told that for any problem solving, you come up with multiple course of action, multiple strategies. You have to choose one best among the alternatives available. So of course, so these objectives are going to be used as a basis for comparing the alternatives course of action. Okay. So these are the features of OR. So I just told about two things now. One, definition of OR. Second thing, features of OR. Just I'm going to see anything there in the chat box. Okay, the thing is, hopefully all are following. Okay, also theory is there, following. You have to, it's not a thing to worry about the theory portion.
Hello, sir. I just wanted to get clarified about one thing. Sir, we are from the beginning, we are talking about problem solving. So in the sense, like what kind of problem we are going to solve using OR?
OR has got multiple number of chapters. One, of course, the linear programming problems, where you have got algebraic equations are there, right? These can be solved using either graphically or using some simplex method called linear programming problems or bigger method and all. Okay, so these words we are going to use in first unit. Second, we are going to get some transportation problems. I'm going to explain all these things in the next slides. Okay, now.
Okay, right? Sir.
Yeah. Next, scope of OR. Yeah, I told only about OR definition and features. Now, scope of OR. The scope of OR is not only confined to any specific agency like defense services, but today it is widely used in all industrial organizations. I think in the beginning, talking about history of OR, UK was the origin state where they started to use OR and all. Then during World War, for deployment of resources, deployment of missiles, many countries like Japan, Germany and all, they used OR technique for deployment of resources. Okay. So, but we can't say that it's only confined to only defensive service. Nowadays, almost all industries are using the OR as one of the techniques for solving their problems. It can be used to find the best solution to any problem, be it simplex or complex. It is useful in every field of human activities. Thus, it attempts to resolve the conflicts of interest among the components of organization in a way that is best for the organization as a whole. That's why I told that one of the features of OR is a system approach. It takes organization as a whole, not going to confine only for one particular part of the organization, trying to solve the problems in various facets. Okay. So it attempts to resolve the conflicts of interest among the components of organization. There are going to be multiple components in the organization. Like I told, manufacturing. You take manufacturing once again, you can say design and the production, manufacturing, quality control. Likewise, you're going to multiple components. So there are going to be so much of there are going to be conflicts arise among the subsections. So trying to resolve these, that is best for the organization as a whole. The main fields where OR is extensively used in OR are given next slides. Okay. Scope now. Okay. Fields: national planning and budgeting, defense services, industrial establishment and private sector units, R&D, and engineering. These are the fields OR is widely used. Planning and budgeting, defense service, industry establishment, and private sector units, R&D, that is research and development, and engineering. These are the fields. Little bit about these things. I'm not going to take too much of time for explaining in detail. Just only I'm going to highlight the major areas in these fields. So in national planning and budgeting, OR is used for the preparation of 5-year plans, annual budgets, forecasting of income and expenditure, scheduling of major projects of national importance, estimation of GNP or GDP, population, etc. So these are the areas used. This OR used for the preparation of all these things. We talk about the national planning and budgeting. Second field, defense services. Basically, formation of OR started from USA Army. So it has wide application in the areas such as development of new technology, optimization of cost and time, tender evaluation, setting and layouts of defense project, assessment of threat analysis, strategy of battle, effective maintenance and replacement of equipment, inventory control, transportation, supply depots, etc. These are the major areas in defense service they are using OR. The third field, industry establishments and private sectors, where OR can be effectively used in the following areas: plant location and setting finance planning. I think the students who have taken OM, where I am planning to take this chapter, that is a plant layout location in operational management is elective. I think they will understand that how OR is used. So OR can be used effectively in plant location and setting finance planning. Second, product and process planning, facility planning and construction, production planning and control, purchasing, maintenance management, personal management, etc. These are the major areas OR can be effectively used in almost all manufacturing organizations. At research and engineering, R&D being the heart of technological growth, OR has wide scope, can be applied in technology forecasting and evaluation. Nowadays, technology management is finding lots of scope. To happen to see some IoT websites, just go through it, technology management, because lots of techniques available, but we are unable to manage those techniques or those technology. And how best you could able to manage those technology and all. So if you could able to refer some IIT websites, go to IIT Chennai and all, just refer some of the articles related to technology management. So just I'm talking about this technology management. So technology forecasting and evaluation, technology management and the project management, preparation of tender and negotiation, value engineering, work or method study, and so on. Okay, of course, there are so many areas are there in engineering also. Value engineering, work and method study, and so on. All. Okay, so I think I can't explain everything in detail in PPT. I think when these things comes during our explanation, we'll discuss about the value engineering, work study, or method study, those things. Okay, it's about the fields of OR. Next about the techniques or tools of OR. Okay, yeah, this is the main focus. We can say these are the techniques or tools, also called as, of course, the same thing we are covering in our syllabus, in fact. Okay, linear programming, the first unit, second queuing theory, sequencing, computation problems. But you're not solving this integer problems. Integer problems not solving it. Okay, I will tell you what exactly these integer problems later. Of course, today only. Assignment problems, and we also come across here traveling salesman problem, where the traveling salesman visiting many cities, how he tries to minimize the distance traveled by the salesman. That's also there in assignment problems. And decision theory and the games theory. I told about the last unit where you were talking about the games theory and all. And replacement problems. Basically, this replacement problem we are covering in engineering economics. Okay, so I think last time we had elective, I don't know. Some students have taken this elective. So replacement at all, we are unable to teach in OR. So it comes under engineering economics only. But these chapters, that is linear programming, queuing theory, sequencing, transformation problems, assignment problem, decision theory, game theory. Those things we're going to deal in this existing syllabus only. And I'll tell you what is the importance of integer programming, I think, after next slide. Okay, so there are techniques of OR. So the first technique, linear programming, I'm going to deal in detail in the next class. It is, I think, from 11 o'clock. Till then, just for 5 minutes, I'm going to take this LPP and these techniques only. In linear programming, the technique is used to find a solution for optimizing a given objective. Objective may be maximizing profits or minimizing the costs. Okay. Why is it called linear programming? Because all the equations what you are using to solve OR problems are linear in nature. There is no squares or cubes in the equation. There is no x square, x cube and all. You are dealing with only x1, x2, x3, x5 like this. You won't use multiple number of variables which are linear in nature. There is no squares or cubes here. That's why it's called as a linear programming. This technique is used to find a solution for optimizing a given objective. Objective may be maximizing profit or minimizing cost. I told that LPP deals with mainly the objective function, that is either maximizing profit or minimizing costs. This is the objective function of linear programming. The objective function and the boundary conditions are linear in nature. Normally, when you want to solve problems using graphical technique, okay, graphical solution or OR, where when you're going to have only two variables like x1 and x2, they're going to have only two axes, x-axis, y-axis. So these x1, x2 can be plotted using the two axes. So that's why you can say that we're going to have some sort of linear equations to come there. Then we are going to draw some boundary conditions to find the optimal solution. Those things we are going to explain in LPP only, I think, in the solving problems. We're going to explain both the objective function as well as boundary conditions are linear in nature. Boundary conditions are linear in nature because what you're going to get the line is straight line. Okay, that's why what equation getting also linear, and the lines are going to be linear only. LPP techniques solve product mix and distribution problems of enterprise. Okay, they are the complex problems are there, like product mix. You're going to get multiple product. You don't think that a company has only one product. They're going to manufacture multiple number of products, like Reliance. Reliance had multiple areas. You got it to only one product. If you take some manufacturing organization, they deal only one manufacturing product. But here we go to Reliance and all, they are into telecommunication, they are into computers, they are into textile, they are into all sort of things. So that's what they call as product mix. When they're going to have manufacture multiple products, they call it product mix. And they're going to have multiple distribution problems also there. So LPP techniques are used for solving the distribution problems. It also used to allocate scarce resources in optimal manner in problems of scheduling, product mix, etc. Okay, it's about LPP. Next, the second chapter, of course, second area of OR, is queuing theory. I'm going to deal a little bit because we are going to deal in detail when we're going to solve problems using queuing theory. This theory deals with the situations in which queue is formed. Example, customers waiting for services, machines waiting for repairmen, and aircraft waiting for landing strips, etc. Okay. Typically, wherever you go, we are going to go for tolls, we are going for making some calls, we are going to wait. Wherever you go, you are also going to wait. Okay. So this queuing theory, also called as waiting lines, dealing with the service part of the queuing theory. How many systems they have got to serve the customers, and how many customers are going to wait for a single server and all. Okay, for example, you go to banks and all. If there is only a single window, if you want to take multiple single queue with multiple people waiting for the getting get served. I think what I experienced during payment of fees in Karnataka Bank, where they're going to have only a single server with a single window, where you want 100 students are standing outside to pay the fees. Of course, nowadays it's online, but still I'm talking about these also. So this queuing theory is with customers waiting for services, machine waiting for repairment, waiting for landing strips, etc. If the queue will be long, the cost will be high due to long waiting for. Okay, suddenly. Okay, these are the cost and the queues are always associated. Okay, I'll deal these things in the detail during solving the problems in queuing theory. This technique is used to analyze the feasibility of adding facilities and to access the amount and cost of waiting time. Okay, for example, when there is only a single server unable to serve the big queue and all, then they're trying to go for adding facilities. Then they're going to have multiple servers. Okay, so that is to save cost, but leading to extra amount also. Okay, so this technique is used to analyze the feasibility of adding facility. Whether it is good to work to add extra server, extra facility, and to access the amount and also the cost of waiting time. These calculations can then be used to determine the desirable number of service facilities. You might have seen that in the highways, you're going to get multiple number of service windows. Okay, but of course nowadays due to the FASTag, that globally that can be avoided. Otherwise, if they're going to issue or they're going to take the money and all that, then going to have multiple number of facilities are required. Okay, it's about the queuing theory. I'll just take another 5 minutes maximum. I'll just check out anything that in the chat box. You are free to express anything in the chat box. So you can continue the class. Yeah, what happened here? There's a problem in continuing the class. Of course, we have completed and by finishing by 11:15, 11:30 maximum. But thing is, it has got only 40 minutes. It's not the paid version. Okay, so to be able to take only 45 minutes maximum, automatically it switches off. So that's why we are going to leave the meeting and we are going to join once again. Okay, that's why you have to join once again from 11 o'clock. Okay, it's not my problem. Of course, it's system and all. Tell me. Hello. Okay now? Yeah, I'll just take lastly one more slide. That's it. Next class, next I'll take at 11 o'clock only. Yeah, sequencing is one more area where it comes under OR. Sequencing. The sequencing models have been developed to find a sequence for processing jobs so that the total elapsed time for all the jobs will be minimum. So typically, the manifesto scenario where you're going to get multiple number of machines, multiple number of jobs, multiple number of workers are waiting to serve, waiting to process and all. That time you need to go for some sequencing. For example, which machine take which job and which operator going to work on which machine. So we have to sequence it. Otherwise, there's going to be so much of idle time because we're trying to minimize the idle time of both. That is, job may be sometimes want to wait, becomes idle time of the job. Machine may become sometimes want to be idle. Machine become idle. Sometimes the person operator going to wait, then he become idle. So these total elapsed time consists of both the processing time and the idle time. So we're trying to minimize the total elapsed time. So sequencing chapter or this sequencing field consisting of developing or finding a sequence for processing jobs so that the total elapsed time for all the jobs will be minimum. The models also help to resolve the conflict between the objectives of maximizing machine utilization and complying with the predetermined delivery rates. Okay, that's about sequencing. Of course, we have a detailed discussion during the chapter when we're going to start unit number 4. Okay, that's all for right now. We'll start at 11 o'clock once again. Please join once again. I think now we have only around how many students are there? 182 students are there as and now. Sir, don't does not queuing theory affect the product quality in certain cases? Yeah, this can't. Queuing theory basically focusing on number of units waiting to serve, number of cutoffs waiting to get served. It is service and the server, the person getting served. Okay, so it does not affect the product quality in certain cases. Of course, sometimes when the so much of raw material waiting for getting processed, it's going to wait for a longer time. It may get affected due to environmental balance. It's going to waste also. Certainly, that's why they're trying to go for multiple number of machines to serve, multiple number of machines to get go for operation now. Okay, of course, it won't affect certainly. Okay, that's all now for this class. And remember, attendance is recorded. We have an option here. So all that's recorded. Please join once again. And I think theory portion I'm trying to cover today only by 11:30 maximum. And tomorrow you can take directly the problems also. Okay. Anything you can chat, you can send a message to the chat box. Hello.
Yes, sir.
Yeah.
Yes, sir.
Yeah, just another. It will take 10 minutes for these things and then start directly LPP only. Yeah, this is one more area of OR. That is, OR is applied for transportation problems. So the transportation problem deals with transportation of a product from number of sources. Okay, that is, like I said, we have some origin, we have some destination. For example, we have some warehouses, we have some where somebody going to use it. Okay, so we are basically transporting goods from warehouses to showrooms and all. Okay, so that involves a movement of a product. Maybe not as a product, maybe raw material or finished WIP, work in progress, or you can say it may be finished product or anything. So transporting from one place, origin to destination, it involves the cost. The basic objective of this chapter is to reduce the transportation cost between two places. So this TP deals with the transportation of product from number of sources with the limited supplies to number of destinations, means some source to destination with the specified demands at the total transportation cost. So we have some demand, we have some supply. To match this supply and demand, so we have some source, we have some destination. So to meet supply and demand, we are transporting the goods or a product from source to destination by minimizing the transportation cost. The main objective of transportation is to schedule shipment from sources to destinations in such a way that minimize the total transportation cost. Okay, the objective of this chapter is to minimize the total transportation cost, and we are moving the goods from source to destination. Okay, that's all about this chapter. It's one of the area of war, that is transportation problems. Yeah, it's very important. That is integer programming. This, in fact, not comes under your regular war. So there are so many chapters called as advanced operation research, where they're talking about dynamic programming and sensitive analysis and integer programming. Just I want to highlight here the features why these chapters are meant for. Say, for example, I told that in a war, we are mathematically formulating all the problems in the organization. Say, for example, a company manufactures product A denoted by X1. A company manufactures product B denoted by X2. Now, X1 and X2 represents product A and product B. Now, the question is, when I want to find the objective function, that is to minimize the cost or maximize the profit, you are trying to find out the number of products A to be manufactured, number of products B to be manufactured. While calculating, what happens, you are going to get some fractional values. Say X1 is equal to 2.1, X2 is equal to 5.3. So there is no product called as 2.1 quantity or 5.3 quantity. There should be always integers. Either company can manufacture 2 products or 5 products only. They can't manufacture 5.3 or 2.1. So typically LPP is going to consider the fractions also. X1 equal to 2.1, 5.3 or 6.7, 5.7, something like going to consider the fractions also. But practically speaking, these are not possible. Okay, that's why we tell that always, or try to optimize solution. You are going to get only the bad answers, not the exact answers. War is an art of getting bad answers. Otherwise, they're going to be the worst answers. So same thing happens here in LPP. When you are going to calculate the number of products, X1 and X2, you're going to get the fractional values, X1 and X2 and all. For example, in the case of transportation, you are going to get cost, transportation cost. For example, doesn't matter for here. Cost means, suppose you're going to get reduce 130 rupees, chalega, 30 rupees 50 paise, no problem. 30 rupees 15 paise, chalega. Because their fractional values are available for the cost. But for the product, it's not possible. In that case, one more chapter called as the integer programming. Integer means complete or whole number. By using the integer programming problem called as IPP, okay, a series of continuous linear programming problems are solved in such a way that the solution containing unacceptable non-integer value are ruled out and the best higher program solutions obtained. So remember here, so there are solutions that are containing unacceptable non-integer values. Okay, like I told you, maximum values 2.7, 8.2, 9.6, something like that. You're going to get the non-integer values which are unacceptable as far as the solution is concerned. That time, this IPP, that is integer programming problem, tries to provide the best possible programming solution. Okay, that is possible in case of integer programming. One more thing is called as the sensitivity analysis. Say, for example, a company manufactures three products, X1, X2, X3 and all. So they can't manufacture in the same quantity. For example, you take example of a Maruti car, for example, they won't have so many variants. For example, if you take Alto Intellect, you're going to have LX, VX and ZX. These are the three variants. So don't think that Maruti company going to manufacture 33.33 of LX models, 33.33 of VX models, 33.33 of ZX models. So they're trying to do some sort of sensitivity analysis because customers are typically they don't know what the product they're going to buy, whether they're going to buy LX or they're going to buy VX or they're going to buy ZX. But how much to manufacture? For example, company intended to manufacture 100 Maruti cars with the three variants, VX, LX, and ZX. Then how much they have to manufacture? How much of LX? How much of VX? How much of ZX they have to manufacture? That time they won't try to do some sort of sensitivity analysis. So, for example, keeping LX as 25 fixed and vary the components of VX and ZX. Let's take, for example, VX 35. So 35 plus 25 becomes 60, remaining 40 ZX. Sometimes they're going trying to make sure that so LS becomes 30 and 60 of VX, 90, 10 of ZX. Okay, because people may not go for more buying the higher end because of ZX quality. So they're trying to maximum more of VX quantity, that is VX 60. So 60, 30, 30, 60, 10. These are the things they're going to manufacture. So they also do some sort of sensitivity analysis by keeping one product constant, by varying one, by increasing one product or by decreasing one product. What happens to the profit of the organization? How much they could able to improve their profit? Okay, those things are comes under sensitivity analysis. So these chapter, one more thing called as a dynamic programming. One more thing called as branch and bound technique, BNB, branch and bound techniques. These are comes under advanced OR. Anyway, we are not dealing all of it. Just I told about there is something called as OR, something called as advanced OR. Those things are dealt by advanced OR only, but we are focusing only on the basics of OR. So this program is not new, but just I told about the significance of why this is also important, because any value you are going to get using LPP are unacceptable values because they are in the fractions. No company could able to manufacture a fraction product. That's why LPP is only giving the optimal solution, not the accurate solution. One more chapter, it is area. Yeah, one more area. Assignment problem. Assignment problem. So, for example, here once again now dealing the assignment. Okay, for example, I told that typically a traveling salesman is trying to visit to so many cities. So, for example, Bangalore, Chennai, Kolkata, Delhi, Mumbai, and back to Bangalore. Okay, so in that case, so he has to visit all the cities. He can't leave any cities. So, what the best route the person can choose? Whether to Bangalore to Mumbai, Mumbai to Kolkata, Kolkata, Delhi, Delhi to Chennai, or Bangalore to Chennai, Chennai to Mumbai, Mumbai to Delhi, and all. So he has to find out the best possible route where he can reduce the total traveling time also and the traveling cost also. So assignment problem and travel assessment both are of course same only. Travel assessment also comes under as assignment problems only. So here in assignment problem, we're going to assign number of jobs and number of machines. For example, job 1 should be done on machine 1, job 2 on machine 2, job 3 on machine 3, job 4 on machine 4, job 5 on machine 5. It's simple. But practically speaking, it's not possible because the processing time of each job may be going to vary. For example, job 1 may take 5 minutes, job 2 may take 7 minutes, job 3 may take 3 minutes. So similarly, accordingly, so they have to use some rule, either short processing time or some of the techniques are there to assign. So which job should be done on which machine? Job 1 maybe on machine 4, job 2 on machine 3, job 3 on machine 2. Something we have to go for matching basically. So that is comes under assignment problem. It's a special type of linear programming problem. It deals with allocating the various resources or items to various activities in a one-to-one basis in such a way that the time or cost involved is minimized and the sale of profit is maximized. Okay, so we're trying to minimize the cost or maximize the profit by properly allocating. Okay, nothing but you can say I told that this job on which machine, job on machine, job to machine to like this. So we're trying to assign to minimize the cost as well as to maximize the profit. Example, manager may like to know which job should be assigned to which person so that all jobs can be completed in the shortest possible time. So the example of job assigned to a person, normally even in textbooks we are trying to assign the jobs on machines. Can be anything, job on machines, job on worker, or a person on machine, anything possible. So it's about assignment problem. Lastly, that is decision theory and game theory. Okay, so decision theory and game theory both are synonymous, in fact, because decision basically involves mainly three things. One is risk, uncertainty, and certainty. Okay, suppose if the outcome is certain, then you are going to follow the standard procedure to get it, because the outcome is certain. You are suddenly going to win because the opponent is weak. Suddenly going to lose because the opponent is so strong. When the outcome is very much certain, then the question of decision theory won't come in picture only. But when it comes in picture, when the outcome is going to be risk, say for example, investment. If you want to invest on fixed deposit, your money is in a bank are going to do some fixed interest every year, so your money is safe because fixed deposit, interest also going to come worth that amount only. You are not getting any extra income because it's a safe investment. For example, the risk involved here, share. For example, you're going to buy some share, you're investing on the share market, expecting more profit. Lots of risk is involved, meantime, lots of maybe expecting good profit also. So the outcome is, of course, risk also. Sometimes uncertainty, okay, we are not sure that we're going to get our money back because repayment problems are sometimes we're going to invest on machinery or some buying and all. So the decision theory is primarily concerned with the decision making under the condition of risk and uncertainty. Okay, so certainly going to be some sort of these three conditions may come: risk, uncertainty, certainty. Certainty won't come in picture because outcome is certainty. And next, game theory is concerned with the decision making under conflict. Remember, game theory. So it is focusing on the action and the strategy. For example, we can give an example of a chess game. It's a game where chess involves two players, player 1 and player 2. So these two players are going to use some strategies. Either they're going to use one strategy called as a pure strategy, means they're going to try to use the same method for entire game. Okay, that is called as a pure strategy. But practically speaking, no one going to use the same strategy because the opponent will come to know that what strategy the person is going to play. So they are trying to go for using the mixed strategy. So game theory dealing with how the strategies are used by player A and player B. What is the outcome for player A? What is the outcome for player B? Okay, and what is the total outcome of the game ultimately? Those things are dealt with the game theory. And hence, both the decision theory and game theory assist the decision maker in analyzing problems with the numerous alternative courses of action and the consequences. Of course, when you say that any game, okay, it has got to have multiple courses of action and the number of consequences for each game. So that's why they use some sort of strategy to win the game, strategy to minimize the loss. Okay, that's about the game theory. So they are the various fields. I told just about the briefing these things. So sorry, more it's not comes under OR. It's a replacement problem wherein machines are going to be replaced due to a technological outdate, or maybe due to the physical wear and tear, or maybe sometimes function inadequacy. They are unable to perform the intended function. That time they are going to replace. It's applicable even for human beings. For example, a person retires, a person leaves the organization, a person dies. Okay, that time they have to fill the positions and all. That time they are going to do some sort of replacement. Anyway, that is not comes under this OR purview, so I'm not going to explain anything about the replacement here. And of course, lastly, limitations of war. Okay, war. Okay, don't think that war is always the best possible method for any managerial problems and all. So here, the magnitude of computation. I told that in the beginning one days. If the variables are very less, with the constraints, nothing but the equations are very less, very easy to solve manually. Suppose when they don't have multiple number of variables are too much, multiple number of constants are there, then it's difficult. That's why one of the limitation is the magnitude of computation. Second, the non-quantifiable factors. So I told that there are sometimes you're going to get the unacceptable solutions. So it is not possible, non-quantifiable factors. For example, in case of assignment, you're going to get multiple solutions. For example, assignment, for example, job 1, job machine 1, job 2, machine 2, job 3, machine 3, job 4, machine 4, job 5, machine 5, and all. For example, sometimes you're going to get, suppose even if you want to allot job 1 on machine 5, job 1 on machine 4, job 3 on machine 3, job 4 on machine 2, job 5 on machine 1, you're going to get some same solution. In that, you come across with the alternate solution. So that time difficult, in fact. Distance between user and analyst. Okay, because somebody is decision making, the user is different and the person code are different, and the time and money costs and implementation is difficult thing. These are the limitations of OR. Okay, so given here all the definition about those things. Implementations are difficult because implementation of any decision is a delicate task. It must take into account the complexities of human relations and behavior. Because that's why I told that in India, war is not so popular because I think probably we are scared of mathematical equations and terms. People don't like mathematics. For example, they like to see the graphs. You show everything on a graph, people are easy to understand. But if same thing you show it in the equations are mathematical terms, difficult to understand. So people think that mathematics is complex. That's why war as in today very difficult to implement in Indian industries. Sometimes resistance is offered due to psychological factors which may not have any bearing on the problem as well as its solution. Okay, sometimes so they may feel that some psychological fear. What the answer you are going to get is maybe may not be optimum, may not be a good solution. There is some sort of a scare about the outcome of the problem. That's why it's difficult to implement. And the time and money costs, OR, it involves lots of calculation, time and money cost. When basic data are subjected to frequent changes, incorporating them into OR models is a costly proposition. Moreover, a fairly good solution at the present may be more desirable than a perfect OR solution available at some time. The computational time increases depending upon the size of the problem and accuracy of result desired. Sometimes you may be satisfied with the outcome result. Okay, chalega. That time OR okay. But when you are expecting that more accuracy about the results, then of course it's going to be some sort of the competition is going to be difficult. At that time you have to use branch and bound technique, or you have to go for dynamic programming, or you have to go for integer programming. They are not so easily. It was lots of time and money. And of course, I told one more thing. It is the limitation of OR is decision between user and analyst. OR being a specialist job requires a mathematician or statistician who might not be aware of the business problems. Remember here, the person who are into the statistics or mathematics may not be aware of the actual practical problems of the other divisions. Similarly, a manager tries to understand the complex working of OR. Thus, there is a gap between the two. Management itself may offer a lot of assistance due to conventional thinking. Okay, so these are the things about the limitations of OR. Okay, that's all about introduction about the first unit. Okay, so if anything are there, just chat me in the chat box. Okay, I think there are some charts are there here. Yes, sir. Anything is there? Okay. Anything they can just message me in the chat box. Hope you understood the first unit. And I'm going to share all these PPTs in the group, or I don't know. Maybe here also I can share in the Google Classroom directly. I have got everything on laptop. I'm there to sharing on the Google Classroom. You can message me, no problem. Message anything. If you want to say anything in the chat box. Is it okay, no? Hello? I'm audible and
Audible.
okay. Yes, okay, now done?
Yes, sir.
Yeah. So just
Yes, sir.
yeah. It's 11:23. I'll take another 10 minutes only, maximum 10 minutes. I'll just I'm going to start the first chapter so that tomorrow it'll be easy for me to start the problem directly. I'm going to take the LPP, just the beginning only. I'm going to start and stop afterwards. I won't take much time today. I think 78 minutes will take maximum. Okay, linear programming. So this is a chapter. In fact, OR is good for solving on blackboard and making you to work on your worksheets. That time it will be easy because normally one problem takes 1 hour to solve in the classroom because we explain for 20 minutes and you take 20-30 minutes for solving all. So one problem, one class. But what happens here in online, it's going to be only one way. I'm going to tell everything and you would listen. I don't know how far you all, but of course I'm not seeing anybody and thinking that you are sitting and listening to me. I'm sincerely on the basis of trust only I'm doing all the things. Okay. Anyway, we're trying to solve a good number of problems even online also because lots of classes are available for online itself. This class today 2 classes, tomorrow 2 classes, and next week 4 classes. Because I'm getting a 12 classes, so I have to complete 1 unit. So you can't do same thing in offline class. If I thought I was going to start in October month, that's why I'm going to try to solve problems in online also. So the first chapter, here I'm going to take only linear programming and only formatting problems. Then later I'm going for one more chapter, game theory. We'll see now, later. So I'm taking the first chapter, linear programming, also called as LPP, linear programming problems. Okay. So this model consists of introduction, LP model, examples of linear programming problems, developing the linear programming models, graphical solution, simplex method, simplex tableau. Okay, you have to make a tableau of an execution problem. And of course, the last those things, that is marginal values, sensitivity analysis, and the complication in applying those I won't take because not included in the syllabus. And duality is there in the syllabus. Okay, I'll tell you what is the duality is later. Don't worry. Right now, I'm going to talk about only introduction about the LPP. Okay. Now understand here. Please just go through once again the entire slide. Mathematical programming is used to find the best or optimal solution to a problem that requires a decision or set of decisions about how best to use a set of limited resources to achieve a state goal of objective. Okay. Somebody may question here, why this LPP? Okay, why do you want these techniques and all? Because any problems in the organization, okay, a decision-making problem, it can be mathematically formulated. Any problems in the organization, okay, not necessarily manufacturing organization, it may be even service also. To take any problems, for example, swimming typically. Swimming has got multiple number of types of swimmings are there. We know only one swim, diving and that's all. But of course, people have got knowledge about swimming styles. You want to have so many are there. Okay, I don't know exactly, but anyway, it's like this. Okay, so you talk about anything, whether going to be manufacturing, whether going to be service sector, going to be sports and all. So there are so many decision-making problems are there. Then that can be mathematically formulated using the algebraic symbols. Those algebraic symbols like x1, x2 and all, that can be mathematically solved. So we are going to get the solution at the end. So to get the solution, there is a need of mathematics here. So this LPP typically uses mathematical programming. Okay, I hope you understood why we are going to use the LPP. Because I told you once again, I put once again here, any problems in the organization can be mathematically formulated using the algebraic symbols or algebraic variables. So those can be mathematically solved. That's why we are using the LPP. Mathematical programming is used to find the best or optimal solution to a problem that requires a decision or set of decisions about how best to use a set of limited resources to achieve goals. Steps involved in mathematical programming: conversion of stated problem into a mathematical model that abstracts all the essential elements of the problem. Remember, it's not so simple that you take some variables and identify. Then what are you going to do to identify variables? Then you have to mathematically formulate. Remember, you have to formulate using some sort of objective function. What is the objective function of the organization? Whether they're trying to maximize the profit or they're trying to minimize the cost. Okay, you have to identify the objective function of the organization. Second, you have to identify the constraints. Okay, constraint. What constraints the organization has got? Maybe having some machine constraints. They have got only limited machines. You have hundreds of jobs. You have hundreds of workers are there, but they have got only limited machines. Machine constraint. So you may have number of machines are more, number of jobs are waiting there, but the workers are less. So you have got workers constraint. You may have layout constraint, no space. You may have that capacity constraints. You may have that capital constraint, money constraint. Likewise, so there may be so many constraints in the organizations. So you have to mathematically formulate the constraints. Okay. So the first important step is conversion of stated problem into a mathematical model that abstracts all the essential elements of the problem. Second, exploration of a different solution of the problem. Of course, there may be many methods available. For example, I let you know in the same chapter, that is graphical theory, simplex method. In that once again, you're going to get the bigger method out there. Okay, so where you have to use, how to use, I'll let you know in the next class. Finding out the most suitable or optimal solution. What are the steps involved in different programming? Linear programming requires that all the mathematical functions in the model are linear. Okay, that's why it's called as linear programming, because all the mathematical functions are linear in nature. That is, no squares, no cubes. Only you're going to get the equations without squares, without cubes. They are linear in nature. Okay, just one simple model here, linear program model. Let x1, x2, x3 up to xn called as the decision variables. For example, company manufactures x1, x2, x3 product, number of products. So all can be expressed using the algebraic variables. So that's why x1, x2 are called as decision variables. Next, there is a cost function, nothing but the objective function, also called as a linear function called z. It is nothing but a cost function. Either you are trying to maximize, that time it becomes profit function, profit. You want to reduce cost, become cost. So that can be either profit or can be cost. So objective function. And a requirement, maximization of the linear function z. Suppose now you are trying to maximize the profit now. Okay, that is z. In that case, z is equal to c1 x1 plus c2 x2 plus c3 x3 up to cn x1. So x1, x2, x3 up to xn are the number of products, and c1, c2, c3 are the profit associated with x1, x2, x3. For example, c1 is the profit you're going to earn by selling x1. c2 is the profit earned by selling x2. Likewise, so you're going to get that function c1 into x1 plus c2 into x2 plus c3 x3. You're going to get the z component, that is the profit of the organization. Then subjected to the following constraints. Remember I told you there are so many constraints: machine constraint, labor constraint, capacity constraints, and all those things are there. So they are called as that is the B1, B2, B up to Bn. They are the constraints. Okay, machine constraint maybe B1, labor constraint maybe B2, and capacity constraint maybe B3, B1, likewise. And A1, X1 plus A2, X2, likewise there are so many things available. For example, A11 is available for B1 for X1. For example, let us say machine, we are going to get 3 machines available for manufacturing X1, 2 machines available for manufacturing X2. Likewise, A1, X1, A2, X2, A3, likewise you're going to have the one constraint for machine constraint. Likewise, you're going to have so many constraints. Also called as inequalities, because you're not going to get equations here. There is no equal sign here. So you're going to get either less than or equal sign, or you're going to get a greater or equal sign. That's why these constraints are also called as inequalities. Okay, because they are involving a less than sign or greater than sign. So the other constraint, where A1, Aij and Bi and the Cj are given constants. Okay, of course, the other constants only. Okay, and last slide. Okay, so this is what we are going to show typically. The linear programming model can be written in more efficient notation, like maximum is equal to Z, okay, subjected to J1 to N. You want to have up to C, J, and Xj subjected to the constants B1, B2, and all, where I is equal to 1 to N. And very important here, that is Xj should be greater or equal to 0. Means whatever the product you want to manufacture should be either 0 or more than 0. Because no company, if they don't manufacture, then becomes 0. X equal to 0. But it can't be negative. Okay, no company can manufacture negative products. Otherwise, if they don't manufacture, that then becomes 0. Or they can manufacture, becomes 1 or 2, 3 and all. So that's why you can say Xj should be always greater or equal to 0. Okay, it's a constraint you have to impose always. So here, in this problem, in this model, you're going to get three things. One is the objective function, that is maximization or minimization. And the second is set of constraints less than equals to or greater than equals to. And thirdly, you're going to put more constraint, that is x1, x2, x3 up to xj are always greater than equal to 0 because they are the variables represent the number of computing activities. It can be 0 or more than 0. Okay, that's all for today class. So tomorrow I will take a problem. So tomorrow sharp at 10 o'clock, please join without fail, so that so I can take problems tomorrow. So the steps or phases are not clear in unit 1. Can you please explain? Yeah, I have got notes with me. I can share you clearly. I think what the phases have shown here, I think they are not sufficient. In fact, a good question. I can share you once again tomorrow morning. Take the steps or phase in OR once again and start problems. Okay, Sufyan. Tomorrow I'll take once again the steps.
Okay, sir. So I guess it is not discussed, so that's why.
Yeah. In fact, I told only about the steps only. I not given detailed information. It's available in notes completely. Tomorrow once again I will share that notes only directly. Okay, on PPT. I'll explain you, and then I directly going for problems tomorrow. Okay, no?
Okay, sir.
Yes. That's all for today.
Thank you, sir.
See you tomorrow 10 o'clock. Bye.